Okay, so today we will be talking about compound probability. This is where probability starts to get a little more tricky, so just make sure that you're paying attention, you understand what's going on. So compound events is going to be two or more events. Independent and dependent events. Independent events are events that don't affect each other. Dependent events are going to be events that do affect each other. Dependent events, the one depends on the other. That's kind of how to think about it. First one, we have choosing a marble from a bag and then spinning a spinner. Those are independent events. Again, they're independent because they're totally different from each other. Picking a green marble doesn't affect what you're going to spin on a spinner. When you pick a card from a deck of cards and then pick a second card, that does affect it. So this is going to be dependent. So it's going to actually affect it. If I draw a 10 of hearts, it's going to affect whether I'm trying to draw another 10 or another heart or whatever card I'm trying to find. The first thing that we're going to do is we're going to be talking about two independent events. And so what we need to make sure we understand with this is that this is two separate events. So when I'm doing two separate things, to find the probability of two things both happening and is both the things happening, I can take the probability of each thing and multiply them by each other. So I find the probability of each individual thing and then multiply the probabilities by each other. So with my first, I have a desk drawer containing 5 red pens, 6 blue pens, 4 black pens, 24 paper clips, and 16 white paper clips. So if you select a pen and a paper clip from the drawer without looking, what's the probability you select a blue pen and a white paper clip? So the probability of finding a blue pen, there are 6 blue pens, and there are a total of 5 plus 6 plus 3, 14 pens. Again, that's going to reduce down to 3/7. The probability of choosing a white paper clip, there are 16 white paper clips. Out of 40 total. That reduces down to 2/5. And so again, to choose to find the probability of blue and white, so blue pen and white paper clip, I'm going to take the two probabilities and multiply them by each other. So 3/7 times 2/5. One way that I can do this, you can do it on your calculator by using parentheses and division, or you can just multiply your tops and multiply your bottoms to get 6/35, which gives me 0.1714, so I can round it to 17.1%. On the next problem, probability that you roll a number less than 3 and the spinner lands on a vowel. So we're rolling a regular dice, and then we're spinning the spinner on the right. Again, remember that, and I guess I should have marked this on the top. This is two separate events. Right here, again, this is two events. And so, again, I want to find the probability of rolling a number less than 3. So again, the numbers that are less than 3. Again, the way that it's said is important. It's not 3 or less. It's not including 3. It's just strictly less than 3. Would just be 1 and 2. So I've got 2 out of 6, which is 1/3. And then the probability that the spinner lands on a vowel. The only vowel that we have here is U. Put a little star by it. Again, vowels are A, E, I, O, and U. So it's going to be 1 over 4. And so the probability of rolling a number less than 3 and getting a vowel is going to be 1/3 times 1/4. So again, I can either use my calculator or I can just multiply my tops and multiply my bottoms. Get 1 over 12. Which gives me 0.083 repeating. So that would be 8.3%. In the next problem, we're going to find the probability of rolling an even number with one die and then rolling a 6 with another die. Again, the trick to this is I'm rolling 2 different times. So this is 2 events. And so probability of rolling an even. Again, even numbers, I've got 2, 4, and 6. It's half the die, so 1/2. Or sorry, I should have done 3 over 6 and then reduced it down to 1/2. And then rolling a 6 with a second die, so probability of getting a 6, there's only 1 6 on a die out of 6 total options. So probability of even and 6 in 2 separate events is going to be 1/2 times 1/6, which gives me 1 over 12, which is again is the same as we had in the previous problem, which is 8.3%. Okay. Go ahead and flip over to the back. And so here, and again, I should have marked on the other one, but when you see that U, that's going to be our OR equation. On your other on your other side of your notes, I should have pointed out that the arch tells us and. This right here is our symbol for and. So to find the probability of an OR happening, what I can do is I can take the probability of the 2 things happening, add them together, and then I can subtract off the and. And so what ends up happening with these is we are going to be, these will be a little bit different to find our and, because on the back, most of these are just going to be one event. And so my one event and is going to be my overlap. I'll talk about that when I get there. So the first problem, students can only play 1 sport per season. And so I want to find the probability that a selected student out of these people play basketball or was on the swim team. So the probability of someone playing basketball is, so 28% play basketball, so 28%. Probability that someone is on the swim team is 24%. And so when I'm finding the probability of someone being on the basketball team and on the swim team, again, I'm only picking one student, so this is one event. And so since it's one event, I want to find the number of students that play basketball and swim, since I'm only picking one. So I'm not multiplying the probabilities because that's what I do with 2 events. This is one event, and so I'm just going to find the number of people that play basketball and swim. And again, it says that students can only play 1 sport per season, so this is going to be 0% because not a person can play basketball and swim because it's the same season. So I can, again, add my probabilities together. So probability of someone playing basketball or swimming is going to be 28% plus 24% minus 0%, which gives me 52%. Okay. The next problem, I've got a bag of chips. I've got 3 blue chips, 6 black chips, 2 green chips, and 4 red chips. I want to find the probability of choosing 1 green or red chip. So again, this is one event. So knowing that, so probability of choosing a green. Let's see, it says that there are 2 green chips. The total number of chips when you add them together gives you 15, so 2 over 15. The probability of a red chip, there are, let's see, 4 red chips out of the 15. And then the probability that a chip is green and red. Again, since it's one event, I'm choosing one thing. I just want to know how many chips are green and red. So I'm looking for one chip that's both green and red. And it doesn't say that there's any green and red chips, so this would end up being 0 over 15. So when I do my OR equation, again, this is my overlap of my 2 events. There are no events, or there are no chips that are both green and red. That's why I don't multiply my numbers together, because I'm choosing one chip. So when I find my probability of green or red, oops, I go 2 over 15 plus 4 over 15 minus 0 over 15 is equal to, and actually it's easier if you don't reduce your fractions. I mean, you can't in this case, but when you're doing this, because as long as they're all the same denominator, when I add them together, I can just add my numerators. So 2 plus 4 plus 0 gives me 6, and then keep my denominator the same. So 6 over 15, which gives me 0.4, which is 40%. Next one, what's the probability of rolling an even number or rolling a multiple of 3? I should have said in one roll. So this is one event. And so I want to find the probability of rolling an even number, so probability of even. And again, below, actually write this with me because it's going to help us understand the and for this example. So this is 3 over 6. So one event, I'm rolling a regular dice, or a regular die. So even numbers 3 over 6. Probability of rolling a multiple of 3. Multiple of 3 would be like basically adding by 3s, 3 times 1, 3 times 2, 3 times 3, going up by 3s. So on a die, you've got 3 and 6. So that would be 2 over 6. Again, I'm not going to reduce because it's going to make it a little easier for me. And then the probability that something is even and a multiple of 3. So again, when I'm doing this, I want to know what number is overlapping between these two things. So I want a number that's even and a multiple of 3. It's as easy as just looking and seeing what numbers in common. If I write what numbers are even and a multiple of 3, 6 is the only number that is even and a multiple of 3, so that's going to be 1 over 6. So when I do my probability that I get an even or a multiple of 3, I'm going to end up doing 3 over 6 plus 2 over 6 and then minus 1 over 6. And so when I do that, 3 plus 2 gives me 5. 5 minus 1 gives me 4, so it's 4 over 6, which is the same thing as 2/3, or 66.7%. Again, if you don't have like denominators or whatever, just do each of these divisions in parentheses in your calculator, and you can just plug it in as one big thing. But that gives me 66.7%. Last two problems here. So a card is randomly drawn from a deck of cards. What is the probability that you draw a spade or an ace? So again, one card, so one event. So probability of drawing a spade. By the way, there are 13 of each suit, and there are 52 cards in a deck of cards. Spades is a suit. If you're not familiar with cards, you've got hearts, diamonds, clubs, and spades. So they're the ones that look like shovels. So the probability of choosing a spade, again, there are 13 spades over 52 cards. Probability of drawing an ace. There are 4 aces, so those are like ones or 11s. So you've got 4 over top of the entire deck, which is 52. And then you want to find the probability that something is a spade and an ace. And so again, I want to know like how many cards, if I'm just choosing one card, how many cards are a spade and an ace. So there's only one ace of spades in an entire deck of cards, so it's 1 over 52. So the probability that something is a spade or an ace is going to be 13 over 52 plus 4 over 52 minus 1 over 52. When I do that, I get 16 over 52. Reducing that into a fraction, I get 4 over 13. Which is 30.8%. And then the very last problem, what's the probability of flipping a head with a coin and rolling a number less than 4 with a die? What we have to realize here is I'm flipping a coin and then I'm rolling a die. So this becomes 2 events. So it's going to change our and probability when we do this. So I'm still doing or probability. So probability of flipping a head, again, is going to be 1 over 2. Probability of rolling a number less than 4. So if it's less than 4, again, that's going to be 1, 2, and 3. It doesn't say 4 or less, it says less than 4, so it's going to be strictly less than 4. So I get 3 over top of 6. And then the probability that I flip a head and roll a number less than 4, this is where I'm actually going to do my multiplication. Since it's 2 events, I'm going to go ahead and do the probability of a head, which is 1/2, times probability that I roll a number less than 4 with, which again is 1/2. That's going to give me 1/4. That's my and probability. So this is the only time, since it's 2 events, that I actually multiply by my 2 probabilities together to get my and. So probability of flipping a head or rolling a number less than 4 is going to be 1/2 plus 1/2 minus 1/4. Sorry, I should have reduced that. So when I do that, again, I got to plug that into my calculator. So I go parentheses 1 divided by 2 plus parentheses 1 divided by 2, close your parentheses, minus parentheses 1 divided by 4, and you get 0.75, which is 3/4, or 75%. Oops. There we go.